When the Army Corps of Engineers discovered problems with the spillway gates at most of its 13 dams in the Willamette Valley, it started making plans for major repairs to these gates. Showing you how a typical dam operates helps explain what a spillway gate does. This is a cutout view of a river. The dark blue water is water that flows into the drainage system behind the dams. The light blue water is water that flows into the system from uncontrolled rivers and streams. When the rains come and the uncontrolled streams fill the Willamette system, the Corps holds water behind the dams. As the river level drops, the Corps releases the water into the system. Every dam has at least 2 ways to release water. Some, like this dam at Lookout Point, have 3. For dams that generate electricity, water passes through the powerhouse and into the river below the dam. The second option at Lookout Point, and the primary route for dams without powerhouses, is the regulating outlet. This is a gated route through the dam itself. The spillway gates near the top of the dam are used to move water through the dams when other routes are unavailable or when the reservoir gets too full. These gates are always a backup system and are not used very often or even every year. Cottage Grove and Dorena dams have no spillway gates. If any one of these systems is not working properly, managing the water system-wide becomes less predictable. When a backup system, such as a spillway gate, is not reliable or in danger of failing, the Corps must take that very seriously. At the time the dams were built, from the 1940s to the 60s, the gates were designed not to open and shut very often. But changing demands for the water have altered the frequency of gate use beyond flood risk management.
But we also have authority and are mandated to manage for hydroelectric power, for fisheries and wildlife habitat, for recreation, for water quality, for water supply of various types.
This requires more of the spillway gates and puts more stress on the system, and now parts of the gates are just wearing out. These pictures show what the Corps found: bending steel and too much friction in the bearings that support the giant arms that lift these humongous gates.
As stuff gets old, it becomes outdated.
A problem first turned up at Folsom Dam in California.
Under operation, it lost a spillway gate. That spillway gate was lost due to the structure being deformed.
Knowing the components at Folsom are similar to those in Oregon, the Corps stepped up its ongoing dam safety inspection and found problems here too.
We discovered some problems with Dexter Dam. We saw that the main structural members, the big herky beams that hold up those spillway gates, showed signs of deformation. There were bends and ripples where we didn't want bends and ripples. These gates are kind of a complex system of components that involve controls, that involve gears, electric motors, hoists, wire ropes, skin plates, gates, beams, and bearings. And all of those aspects, all of those components have to be functional for the system to be reliable. If we don't fix the problems that we have in front of us, we could experience a catastrophic gate failure. We don't want to do that.
The Corps is moving forward to return spillway gates to their full strength and reliability using current design standards. And those parts and pieces are being repaired on a priority basis.
Right now we're prepping the gate for the installation of new trunnion arms. They'll be here Friday, and then once Friday rolls around, we'll fly the new arms in and weld it in place.
Work on 2 gates at Dexter Dam fully restored their strength and reliability. Repairs at Foster Dam and initial work at Fall Creek, Hills Creek, and Green Peter Dams are complete. Additional work is coming, as much as possible, when funding is available. As a precautionary measure, until repairs are complete, less water will be held behind the dams.
The risk is really pretty incremental. It's pretty small. And as a consequence of having some stress on these spillway gates, we are holding reservoir elevations a little bit lower in the wintertime, and we've effectively diminished our storage capacity, the potential to store water, by about 15% in order to keep stress off of the gates. Typically, in an ordinary year, we never have to do that.
While the spillway gates are an important part of the overall system, don't forget they are a backup for releasing water. If the Corps needs to open the spillway gates to reduce water pressure on the gates, people living right along the river may notice river levels higher than normal for longer periods.
So we really want people to understand what's going on. We've got some issues. We're dealing with those issues. We're affecting repairs in a very aggressive manner, but it's going to take time.
The question for many homeowners is what now? What can you do to protect your property if there is flooding this year or flooding any year? We talked with some experts to find out what your responsibility is and what you can do to protect your property. We also found some great websites that can show you how to monitor river levels, how to monitor how much water's behind the reservoir, and even the weather forecast. We'll have that coming up next.